All right, today we are taking it way back to about elementary, maybe start of middle school, and we're literally doing just basic long division. We need to know this because we're going to use it to do long division of polynomials. So today is literally just a review. It's going to be this simple. I'll show you when there's variables, what do we do, and that's it for today. You'll notice the notes look like kindergarten stuff, and the worksheet looks like fifth grade, kindergarten, elementary school stuff. All right, so we start with number one. It's basic long division. Divide. We have 529 divided by 3. We take it one at a time. How many times does 3 go into 5? One time. We write that. So 1, then we do 1 times 3. We get 3. 5 minus 3 is 2. All right. Then you see the arrow. We bring the 2 down to see 22. How many times does 3 go into 22? The closest possible one is 7. 3 times 7 is 21. So 7 times 3, we write 21 down here. All right. Then this is 0. This is a 1 left over. And then we bring that 9 down. 19. How many times does 3 go into 19? That's 6 times. 6 times 3 is 18. All right. 19 minus 18 is 1. Our remainder is 1. And that's it. You take it one step at a time. This is going to be very important when we do dividing polynomials, okay? Long division. Moving on to the next one. I'm actually going to change color so it's easier to see. We'll do red. All right. Number 2, we have 964 divided by 8. We go one at a time. How many times does 8 go into 9? That's one time. All right, 1 times 8 is 8. 9 minus 8 is 1. Bring that 6 down. How many times does 8 go into 16? Exactly 2 times. 2 times 8 is 16. Again, this should be really simple. You're probably wondering, why are we doing this? Trust me, it's important. 16 minus 16 is 0, 0. All right. And then how many times does 4 go into 8? 0 times. Make sure you make note of that. If it's below, 4 is less than the number outside here, it obviously can't go into it. Okay? 0, and then 0 times 8 is 0. So when we subtract that, we get 0, 4. So our answer is 120, remainder 4. And again, that's it. I'll do a couple more and then I'll show you bigger ones. It's the same steps. Let's see. Actually, we see the paper didn't even load, so I will move on to this part. Okay, make sure. Okay, we're good on this. So we're moving on. I'll keep red. We see old school long division. That's a big number, but it's basically 2 divided by, and then this long number 8, 2, 3, 4, 5, 4, 6 divided by 2. Again, you take it one number, one step at a time. So 8, how many times does 2 go into 8? 4. 4 times 2 is 8. 8 minus 8 is 0. Bring this 2 down. How many times does 2 go into 2? That's 1. All right. 1 times 2 is 2. That equals 0. And then we bring the next 3 down. This is going to be a long time. We're going to keep going one number at a time. 0, 0, 3. Then how many times does 2 go into 3? One time. But this time we're going to have a remainder because 1 times 2 is 0, 0, 2. All right, subtract that, and we get 1. Then we're going to bring this 4 down. 14. How many times does 2 go into 14? 7 times. 7 times 2 is 14. We're back to no remainder. Scroll down. Oh, I guess not. All right. So 14 minus 14 is 0. All right. Then bring down this 5. You see where I'm going with this? How many times does 2 go into 5? That's 2 times. Bring that down here. I'm going to move over here. 5. 2 times 2 is 4. Okay. 5 minus 4 is 1. Then we bring down the next number. Again, that's a 4. So I'm drawing the arrow, but again, I'm going to bring it up over here. 14. How many times does 14 go into 2? Or how many times does 2 go into 14? That's 7 once again. 7 times 2 is 14. 14 minus 14 is 0. Then we bring down the last number, which is 6. So 0, 0, 6. How many times does 2 go into 6? That is 3. 3 times 2 is also 6. 6 minus 6 is 0. Our remainder is 0. So our final answer, after all that, we took it one number at a time, is 4117273. And I know what you're asking. Why are we doing all this work when I can just put it in the calculator? Because we're not going to be able to put polynomials in the calculator. We're about to divide polynomials right now. I just want to do one like that of long division. So we scroll down. Here we go. Dividing polynomials. Now, we know when multiplying polynomials, when we multiply those, we multiply the numbers, but then the exponents, we add them together. So if when multiplying we add exponents, when dividing, we're going to subtract exponents. It's that simple. So we see number 1, 28x to the 8th, and then times y to the 9th divided by 7x to the 6th times y to the 1st. There's no number there, so we know it's just y to the 1st. It's literally this simple. Let's do like terms. 28 divided by 7 is 4. It's going to be on the top, all right? Or then x to the 8th divided by x to the 6th, you're going to subtract. We see the bigger number is on top. Make note of which number is bigger, the top or the bottom, because whichever one has the higher amount of exponents, it's going to stay on that side, whether it be top or bottom. That'll make sense in a sec. But x to the 8th divided by x to the 6th, or think about it as 8 minus 6, that'll be x to the 2nd. That's going to be on top because, again, like I just said, 8 is bigger than 6, so it's like all those 6 cancels out, and we're left with x to the 2nd up here. And then finally, we have y to the 9th divided by y to the 1st, or 9 minus 1, and the y is going to be on top, y to the 8th. We see there's nothing on the bottom, so we don't even have to write this fraction, and our final answer is 4 times x to the 2nd, and then times y to the 8th. And that's how you divide polynomials, okay? It'll be a little bit trickier when there's bigger numbers on the bottom, as you can see for number 2. All right, so I'm going to show you how that is, and then we're done. Don't worry about number 3. So we're looking at number 2. We have 7x to the 4th times 14y to the 13th divided by 49x to the 5th times 2y to the 2nd, okay? So we go here, 7 and 49, those can be divided. We get x to the 4th, oops, excuse me. We get 7, we're looking at 7x to the 4th, not just the number, but 7x to the 4th over 49x to the 5th. So all that's left over, we see the bigger number is on the bottom. So we're going to do 49 divided by 7, which is 7. That comes down here. X, what is x to the 5th minus x to the 4th? That's x to the 1st, so we just leave it as 7x. All right? So the first part is done. Now we need to look at the y's. 14y to the 13th divided by 2y to the 2nd. We see the bigger number is on top, so 14 divided by 2 is 7y. All All right, that's gone, that's gone. Y to the 13th minus y to the second is y to the 11th. All right, and now from here, we just divided. Now we just need to simplify. If we can simplify, we are going to. So 7 and 7, both of these numbers can be divided by the same thing. We're not dividing them by each other. We're not doing 7 divided by 7. It just happens they both have the same number to be divided by, which is 7. The way I mean that, for example, if it was, let's see, if it was 3y and 6y, we wouldn't divide by 6, we would divide both by 3, and our final answer would be y over 2y. So over here, we're doing the same thing. We're simplifying. It's just happened they're both going to go to 1. So we're going to simplify 7y to the 11th over 7x. So we divide the top and the bottom by 7. And our final simplified answer is y to the 11th over x, or x to the first. All right, and that is how you do old school long division and how you divide polynomials. Today should be a review. It should bring back memories. Shouldn't be too bad, okay? Tomorrow we'll get into long division. Make sure you pay attention because that can be confusing, all right?